Okay, yesterday we have covered till like Boolean and NaN type. So today we'll continue with other data types as well. Okay. So before that, let's start with one concept, which is type conversion or type casting. Okay, this type conversion or type casting is nothing but we'll use this to convert one data type into other data type. Okay. So as name suggests, we are converting one type to other type. So how we can do that? Like we have inbuilt Python data types, right? Keywords for Python data types. We can make use of them and we can convert them. Here we can convert only allowed types. Okay, only compatible types. We can't convert everything from one to another. Let's say we have integer number, we can convert it into float. And then we have string, and string should contain only numeric values or decimal places. Only then we can convert it into string like integer or float. And we can convert any Python data type into string, like it may be anything. We can convert it into a string type. To see examples like when we do int of 22.55, 22.55 is basically floating point number. When we are converting it into int, it will convert it into integer, which will be 22, and it will adjust the memory accordingly. Okay. Let's say we have defined a is equal to 22.5. So Python will allocate some amount of memory since it is a floating point. When we convert a into integer type, then the memory will be automatically readjusted to hold the integer value. Same happens with float of 22. So when we are converting integer to floating point in this case. And then string of 22. We can convert strings or floating points into, integers or floating points into string. And you can see this more complex data type, which is a string of 1, 2, 3, 4. So basically here we are converting Python list into string format. Okay. And then we have many other data types, like we can convert a normal decimal number into binary value, and then we can convert it into hexadecimal, and then we can convert it into octa. We have this octagonal literals, okay, which is similar to hexadecimal. We have octadecimal as well, which will start with 0 and O. When it comes to hexadecimal, it will start with 0x, and binary will start with 0b. And if you see, like, this is the string basically, float of 355.52. And when we convert it, string into float, it will be converted into floating point. So as I said, we can convert only Python compatible data types, nothing else. Okay. Let me share my whole screen. Just give me a second. Okay, let me just spin up a collab session so that we can check practically. So let's say we have one variable which will be holding value of 8.9. This is nothing but a float. You can check it using type keyword, right? The data type. So currently A is floating point number. I think the kernel is initializing. Just give it some time. Okay, if you see this, A is initialized with value 8.9. And the type of A is a floating point. Okay, now when I do int of A, I'm assigning it back to A only. A is equal to int of A. And if I'm checking type now, you can see it's converted it into integer. Okay. And if I try to do same thing using string, let's say I have 25.67, and I can either convert it into int or I can convert it into float. Okay. Because it's kind of compatible. The characters within string are kind of compatible with integer as well as floating point. So I can do any of these conversions here. Sorry. And just click on run. Okay. Okay, sorry. Yeah, you can see this. We have this integer string 25.67, right? This is a floating point number. Sorry, my bad. Okay, we can convert it first into floating point. As I said, like a is equal to, let's say this will be AF, which will be A converted to float. Since the string contains a number in floating point format, we can convert it into float first. And then we can convert it into integer. Let's say it is AI. And I'm trying to convert floating point value into integer over here. Okay, if you see, this has been done. So now if we check type of A underscore F underscore I, so you can see these are converted to float and int, okay? And if as you have seen like while ago, if there is any incompatible format, let's say I'm adding some number like letter over here, and if I'm trying to do conversion, it won't happen. Saying that could not convert string to float. The reason being it is encountered some other like value other than the numbers. Okay, it holds true for all the types, but you can convert any sort of things into string. Let's say we have this Python list. Okay, if you check, let me assign it to ls and type of ls. Okay, okay. Now the this is ls is basically list. Okay, so I can convert list into a string using the str keyword. When I'm doing str of ls, what happens? This will be converted into string basically. So in this string, the list definition in this format holds some meaning over here. Like these brackets, like opening and closing brackets, indicates that this is a Python list, and within that we have integer values 1, 2, 3, and 4. When it is converted to list, all the things here will be converted into string format. Okay, this will be one string. This bracket will be treated as a string, and this number one will be treated as a string. Two will be treated as a string. So everything will be converted to string. Okay, and let me get back to PowerPoint. Okay, this is the type conversion. You can like there may be cases where you need to like dynamically convert one type to another type. In that cases, you can make use of this thing. Or if you feel like you are getting some different format, let's say you are defining an application and you are expecting some floating point values there. Uh, per se, we have this A's, right? A's may be in years and months. So you might be kind of giving some floating point number there, but the user is entering integer value. So you have programmed your code in such a way that it should only work with floating point number. So in that case, what you can do is you can just convert it into like integer to float using this type conversion. That is kind of one typical use case where you can employ this type conversion. And I think you have already done this assignment, right? So I got only one like one answer from Bano and no one else pinged me. So just if you have tried it out, just ping it over me in WhatsApp, like or else like personally in Teams, okay? And coming to Python operators. So as name suggests, operators are used to for perform some sort of operation. It may be arithmetic or it may be logical or it may be other assignments. Okay, any operator. Okay. So these are some basic operations available here. Plus, as you know, like it's addition, like a subtraction, multiplication, division, and we have this if we are giving two these divisions, it will become floor division. Okay, floor division is nothing but we'll get quotient of the like quotient of the this division. And then modulus operator will provide us reminder. So when we are performing division, there will be two components, right? One will be the quotient and one will be the reminder. So we can get them separately using this. And if we are using only a division operator, it will provide us both quotient as well as reminder, okay, in decimal format. And star is exponent. We can kind of use it for power, like 3 power 2 or 3 power 3 sort of operations for exponential operations. And then we have assignment operators. As you know, equal to will be single equal to is used for assignment. Like we have like we have initialized many variables in our first class, right? A is equal to 8 sort of thing. So equal to is assignment operator. And when we use a double equal to, then that will be comparison operator. To check, like to compare two variables, we'll be using double equal to. And for assigning variables, we'll be using singular equal to. And then we have some what you say complex operator. This is complex assignment operator. Uh, what this will be doing is it will take one number like the variable on the left side and it will increment it using some value defined on the right side. Okay, I'll explain it practically what it means. Okay. Before moving to this logical operators, let's try out these arithmetic operators in our like hands-on. You can directly do some operations like without initializing any variables. You can perform this like 2 plus 8 or 2 minus 8 sort of things. Okay. Or else you can assign them to variables. A is equal to, let's say, we have 10 and B is equal to, let's say, we have 3. You can perform operations on these variables using these variables like A into B will give us result of 30. And if we use here like this division operation, it will provide us result in decimal value. Okay. And if I am using this floor here, floor division, you can see I'm getting only quotient. Quotient in the sense like it won't give us reminder. Like 3 by 10, like 3 is exactly like in multiples of 3 will go till 9, right? So we are left with only one that will be reminder. So we are getting quotient. And for accessing reminder, you can use modulo operator, which will provide us the reminder, which is 1 when 10 is divided by 3. And let's say I need 10 power 3. What I can do is I can do A double star B. So it will provide me like 10 power 3, which will be 1000. Okay. This is a exponential operator. Okay. And let's say I am trying to, we have covered some complex operator, right? Which will be A plus or equal to 5. Okay. Now here, the meaning of this will be A is equal to A plus 5. Okay. The meaning of this particular operation here is A is equal to A plus 5. It will be taking the variable on the left side and it will like add this particular value to this, which will be now we should expect 15 from the result. Okay. I think it's not, let me print it out. Sorry. Since this is assignment one, it won't print out. Now I'll try to access the variable A. Initially, okay, I need to reinitialize the variable. So now I have done the reason we are getting 20 is I have performed this step 2 times. So it has added like 5 value 2 times. Now you can see 15. We are getting 15, right? Now the A value is 15. Now what I'll do is I'll just subtract 5 from A. And if I try to access say now, A will become 10 again. Okay. We can perform any sort of operations using this shortcut. Like you can give A into equal to 5. Now it will do like it will just multiply A with 5. And you can access same using this variable A. Sorry, I taken text. Okay. Let me just try to access this now. Now you'll get a variable of like since A is already 15, like 15 into 5 will get 75. So you can use any sort of complex operators like this, like instead of going with this long way. And then we have logical operators. So logical operators are kind of mainly used for controlling our flow statements, like by evaluating conditions and controlling our flow control statements, like conditionals and while loop sort of things. Okay. And there are three logical operators we have. One will be logical and. Logical and, what it will do when both conditions are true, it will evolve to true. Like final result will be true. When logical or, in logical or, we need only like any one condition true, then it will evolve it to true. And what is logical not? Logical not is kind of, it will completely reverse the result. Okay, it will completely reverse the result which we have. If the final result is true, not will make it false, and vice versa. And then we have identity operators. This is a little bit tricky, and we won't use it for our day-to-day tasks. But yeah, since but you should be aware of this. So it will be used to compare the objects. Okay. So equal to will perform comparison between the values. Okay. This identity operator, it will compare the actual object, including the value as well as the memory location where it has been stored. Okay, if A and B are same objects, then like we'll get true from this using this identity operator. And when A and B are not same, then we'll not get true. Okay. For suppose we have this variable X, which is a basically list, and it's holding apple and banana. And we also have one more variable which is also holding same apple and banana. And I'm performing assignment operation here. Like I am assigning z, like initializing variable z with x, which will be apple and banana. And when I evaluate it, z is x, it will give me true. The reason being both x and z are essentially same objects. Okay, understood, right? So now, can you guys guess what I'll get when I evaluate this condition when x is y? We have this x, y, z here. And when z is x, I'm getting true. Like when x is y, what will be the result? Just guess. Just carefully observe this assignment and okay, false. The reason being,
It's not same. X and Y are different.
okay. So the reason I'll explain, okay, yeah, it's false. So let me initialize here it with same variables, like A is equal to banana and orange, okay? And let's say B also is the same thing. Now we have two list with us, okay? And I'm doing C is equal to A and A is C. I'm trying to run this comparison and I'll get true. The reason being I'm assigning A to C, right? And we have A is B. The reason why we are getting it false is if I do same thing here, let's say I have X is equal to 8 and Y is equal to 8, okay? I'm doing X is Y. So in this case, you'll get true because if you see x is equal to 8 and y is equal to 8, both are kind of different variables, but they are initialized with same value. We are getting x is y. Okay. When it comes to this thing, even here we are doing same thing. Like we are having a is equal to banana and orange in list and b is equal to banana and orange in list. But in this case, if we are evaluating a is b, we'll be getting false. The reason being, this compare identity operator won't check for the values here. It will check for the memory location. Okay. I think in yesterday's class, we have covered about Python memory. Like if we are initializing them with same value, then instead of creating new memory location for Y, it will point it to the X memory location. And if you can check same like ID of X comma ID of Y. We are trying to access memory location, you can observe both memory locations are same. Okay. But in this case, even here we are initializing using the same value, like in both cases, but it is evaluating to false. The reason being A and B are being stored in different memory locations and both are completely different objects. Okay. If you check the memory locations here, you'll get different memory locations for A and B. The reason being, even though these were having same values, if you observe, these are kind of complex data types. So this is the list data type in Python. So basically, list are mutable objects. So list can be modified in between. So that's the reason Python will be allocating new memory for complex types like list, dictionaries. So it won't assign, even though the object will be same. If you are initializing it with different variables, Python will allocate different memory locations. Okay. So we'll use this identity operators for these sort of comparisons. So these are useful in some high level system design and all, but we won't use. And then we have membership operations. Okay. This is kind of used to check membership of one object in another. Okay. Let's say we have two things in here. One is in and one is not in. Okay, not is nothing but this negation operator, right? It is invert operator. So it will kind of just invert the result of in. So if you check here, we have list 1, 2, 3, 4, 5. List is having elements 1, 2, 3, 4, 5 with us. Okay. And I can check, like, let's say I need to find if we have 5 inside list or not. So we can just give 5 in ls, which is nothing but list. So it will give, like, it will evolve to true, like indicating that 5 is part of the list ls. Same thing like 10 in ls. Since there is no 10 inside list, it will kind of give us false. And then we have 12, 12 not in ls. So it's we are checking like if 12 is present or not, but we are expecting 12 not to present in the list. So that's why it will give us a true. And then we have bitwise operators. Even this is kind of we won't use it for day-to-day things, but there are few things like genetic algorithms sort of things. Okay, those are highly advanced algorithms where we'll be using these operations basically. Okay. And if you see, there are like AND operation, which will be kind of sets both bits to one. Okay, if you see, we have this logic gates. If you remember in our during our engineering days, we'll be having logic gates, right? In logic gates, we'll be having AND gate, OR gate, XOR gate, NOT gate, sort of things, right? So these are basically same operations. We'll be taking binary value and we'll be performing bitwise operations on that. Okay, I'll just show it practically here. Let's say we have A is equal to 0B. Since binary will start with B, I am making B is equal to 0B 10110110. Okay, these are A and B. Okay, now if I am performing A and B, okay, I think this will provide us result in decimal. So I'm just converting it into binary, the result which we are obtaining, so that we can clearly take. See, if you see here, I am performing a logical AND operation between value A and value B. Okay. If you see here 1, 1. So 1, 1, since it is AND operation, both bits should be 1. Only then it will become 1, right? So if you see the first one is 1, then we have 1, 0. So it made it 0. And then we have 0, 1. So it makes it again 0. And then we have 1, 1. So it makes it 1. So all the other things we don't have like both ones, right? So it will convert them to 0. So basically this is logical AND operation. In case of OR operation, any of the bits should be 1. Okay. Any of the bits should be 1. If I make some 0, if both are zeros, OR operation will give me 0 result. If you see here, apart from this second position, all the other bits have like at least 1 in that, in their places, binary places. So I'm getting result of this one. Only the second will be evaluated to 0 when I perform OR operation. Okay. And I can do XOR. I'm doing XOR operation here. So basically XOR, what it will do, for XOR, we should have any of the bits 1. Okay. If both bits are 1 or both bits are 0, then it will make them 0. If any of one bit from A and B is 1, then XOR will evaluate it to 1. Okay. Same thing. We have invert all bits, right? So what it will do is, let's say I'm doing this. Okay, binary. We have a with us, right? We just need to use the negation operator. Though this is the operator which we'll be using for many other things. Okay, what it will do is it will kind of just invert the bits which we have. This result is not bit it's very. We need to perform two levels of operations here, two composite and one composite. So that's very complex one. If you are interested, you can just explore like why this negation of A is returning this result. So you'll find a lot of this mathematical concept there. Like it should be like we'll be first performing two's composite conversion and then one's composite. So hence we'll be arriving at this result. Okay. And then we have zero fill left shift and zero fill right shift. These are the kind of very less used. Okay. But anyways, we can kind of just check the okay shifts left by pushing zeros from the right. Okay. What left shift will do? We have this A with us, right? What left shift will do? So this is basically left shift, right? So it will be shifting bits towards left. Okay. From right to left by two positions. Okay. If you see here, what it will do, it will push two zeros from this side. From initially we have one as the last one in here, right? Now when I did zero fill left shift with two zero values, two positions. So what it will do, it will introduce two zeros from left side of the this thing, like from right to left. It will push the whole bit from right to left. So I'm doing same thing using this zero fill right shift. What it will do shift the bits from right to left. Okay. In first case, we have done it from left to right. Since we have both ones here and we have made two bits, shifted two bits, it will retain everything. In this case, I am shifting them by two bits, right? So it will introduce two zeros here. Now this will become after result, this will become 0 0 11 1 0 1 1, and it will be kind of throwing last two bits away. Like it will just discard them and it will introduce two zeros here. These two zeros are nothing but like these don't have any significance here, right? So the final result here will be 1 1 0 1 1. Again, this is kind of very least used, but anyways, you should be aware of that. And then we have operator precedence. So this is also one like important aspect of the even we have this during our high school, just like how operations will be performed in which order. So if we have some complex equation with us, we need to know how Python will be performing that mathematical operations on that. Okay. Coming to order, parentheses will be given first preference. Okay. Parentheses have top priority in the equation. Python will first evaluate all the parentheses available in the equation. And then it will perform exponential operation. After this, we have this multiplication, division, floor division, and modulo. All these four have same priority. And fourth will be plus and minus. Okay. Subtraction and addition will be the least priority. It will perform those operations at the very last. So in case of third and fourth, we have same priority for different operations, right? In that case, what it will do is same as our mathematical thing. It will proceed from left to right. It will start from left of the equation, and wherever it encounters star like multiplication or division, it will perform it first. Then it will move to the next operator. So in case of same precedence, it will perform operations from left to right. Okay, and then just give me a second. I think we have this laser pointer or highlighter also here. Okay, now if we come to this equation, we have 8 plus 9 into 12 plus 5 divided by 4 exponential 2 minus of 2 plus 8, right? So the final result from this will be 194.3125. If you carefully observe, the very first thing it will do is parenthesis. So this 9 plus 18 will be evaluated to 17 and 8 plus 2 to 10. Same way. Next, it will check. Then we have encountered exponent here, right? It will make 4 power 2, which is nothing but 16. Okay. And then we have multiplication and division. Okay. Since the multiplication is first, like it is encountering multiplication at first from left to right. First, it will perform this multiplication and then it will proceed 5 by 16 division. Okay. Next, it will perform division and it will remain like this. So, in the very least, we have plus and minus. Again, this will be evaluated from left to right. So it will just add 204 with 3.3125 and then we have minus, right? It will subtract that result from minus. So if you kind of evaluate this practically in your Python this thing interpreter, you will be getting same result, which will be 191.3125. So this is kind of one important aspect which you will encounter in most of the interviews. Like this seems simple, but they'll be kind of asking bit tricky questions and they'll be asking what result the Python evaluate for this expression. So just pay attention to this operator precedence. Okay. So this is for simple data types and operations. And then now we'll be moving to the sequence types. Okay. And so far we have covered simple types like integers, floats, decimals, Boolean types, which will be holding single value. When it comes to sequence type, this will be holding sequence of values. Okay. In the sense like we have list can hold any number of individual simple values like it can hold integers, it can hold strings, it can hold decimals, anything. Similarly, string. Even though string don't seem like a sequence, it is actually a sequence type. The reason being, it is holding sequence of characters. Okay. In string, each letter will be one treated as a character. Okay. So it is kind of basically holding sequence of characters, and you can perform all the operations which we can perform in the sequence data types. Okay. So coming to string, string is an immutable data type. Okay, immutable and mutable. So mutable in the sense, okay, in mutable we can do some changes. We can mutate some changes. Mutate is nothing but making like whether it is changeable or not. So string is strictly immutable. So once we initialize a string, we won't be able to do anything on the string. You can't do any sort of operations on the string. Okay. And then we have this like no character type. So in C and CPP, we have character type. Okay. If we have single character, then they'll be treating it as a character type. But in case of Python, even the single character will be treated as a string of length one. Even though we have assigned a st is equal to a, that will be considered as a string with length one. Okay. How we can initialize string? Okay. How we can define string value? So we need to enclose it in either single quotes or double quotes. And like any variable which is initialized with single or double quotes will become a string in Python. And we can define multi-line strings as well. So yesterday we have seen comment and multi-line comments, right? So multi-line comment is nothing but multi-line string, okay? We need to use triple quotes in this case. We need to use three single quotes or three double quotes, and we can span the string of any length. We can kind of type paragraphs in between. It will be considered as a single string, which will be multi-line string. Okay, and let's say we have this. Let's define our very first string, and this will be hello. I'm your first string. So this will be my first string, right? And you can do this using single quotes or double quotes. Python will accept both things. But one condition here is within quotes, you can't use the quotes again. Okay. Say hello. I am okay. I am right. For your, if I am trying to use double quotes again, you can observe the Python will throw error saying that syntax error. The reason being you won't be able to use quotes inside quotes. But if you can use, like, if you give single quotes here, then Python will accept it. Okay. I think I made some mistake here. So within double quotes, you can't use double quotes, but you can use single quotes. Same with single quotes. Within single quotes, you can use double quotes. You can't use like same quotes inside. For using same quotes, like we have this double quotes here, and for using same quotes within string, we have some restrictions and we are not supposed to use single quotes. In that case, we can use them. We can indeed use the double quotes, but using escape characters, okay? Escape sequence. So we'll be covering the escape sequence in separate lecture. Just remember the but thumb rule is we can directly use same quotes within the string, okay? Which we have initialized string with. Okay, this is our first string. So now we'll be checking what are all the operations which we can perform. So first concept is indexing. Okay, indexing is nothing but this string is kind of sequence, right? This sequence will be having index. Index is nothing but it's a sequence number. Okay, the hello is the first position here. Hello will be calling first index position, and from here it will be keep on going first, second, third, fourth, fifth, sixth sort of thing. So index is nothing but the we'll be using it to identify the positioning of the string. Okay, so in this case, I am trying to identify what's in the position 4. Okay, STF4. If you see here, HELLO. H is 1, right? 1, 2, 3, 4, 5. 5, right? O is in fifth position. But in result, we are getting like we have given fourth position, but we are getting O here. Ideally, we are expecting L here, right? Which is in fourth position. Yeah, yeah, exactly. So in Python, indexing, like in any sort of sequences, indexing will start from 0, not from 1. So if you are supposed to access the fifth character, then you will be giving the fourth here. Similarly, like you need to just remember that indexing will start from 0, not from 1 in Python. So this is kind of simple indexing. It's always starts with 0. Okay. We can also perform negative indexing. Okay. This is positive indexing. Negative indexing, it will just start from the end of the sequence. Normal indexing will start from beginning and the negative indexing will start from end. But in negative index, we don't have any zero sort of thing. The reason being zero is the only zero. So negative indexing will start from -1. Okay, always starts from -1, and it will go keep on coming in like one step behind, like -1, -2, -3 sort of thing. Okay, this is indexing, and then we have slicing. Slicing is the complex form of indexing. In indexing, we'll be using only one this thing, one index position. But in case of slicing, we can like we can access multiple index positions. Okay, we can access set of like range of indexes, like from first position to fifth position, or from n position to like n-5 position, sort of thing. Okay, so basically these are the different ways of using slicing. If you see the very first case here, we have st of 0:3. Okay, this colon here, which we have used, that is used to differentiate between the start and end positions. Okay, so what this indicates is we need to access characters of the string from position 0 to position 3. Okay, position 3. So you need to remember that this 3 here, it is kind of exclusive. Since Python is starts from 0 to 3, here we are trying to access 0 to 3 like elements, right? But the 3 is excluded from the index. We'll get just 0, 1, 2. So always the end position of the slicing or range functions will be exclusive. Okay, we won't consider the last value. If we need to access values from 0 to 5, we can give 0 to 5, but as per Python, fifth one won't be considered. We'll be getting 0 to 4. Our intuition behind this is 1 to 5, right? Because human registries will always start at 1 and will go to 5. But in case of Python, it will start from 0. So that's the reason the last index is always exclusive. It won't consider the last index position. In this case, we'll get 0, 1, and 2 characters. Since 2 is in third place, we'll get that. Okay. We can also perform negative slicing. Okay, slicing using negative indexes as well. Here, if you see -5, -1. -5 is the very end position. Okay. Sorry, -1. And -5 is fifth position from end. Okay. It will try to give us string slice starting from like end -5 position to end of the string. And then we can just initialize it with the left like range. If we are doing that, it will start from 0 and it will give all the characters available in the sequence. All the characters are all the indexes available in the sequence. And we can also perform write this thing, indexing. So in this case, it will again start from 0 and it will give all the characters available for us. What I have did here is I am just taking length of string, which will be the maximum length available for this sequence. And then we have this third one introduced in the slicing. So this third one is nothing but step. Okay. Let's say we have 0 to 6. If we are giving just 0 to 6, it will start from position 0 and it will go till 6th position. But when we are giving 2 here, what it will do is it will do the same thing in steps of 2. Okay. It will start at 0, then it will skip 2 positions. It will skip 1 and 2 positions and will provide us third position. And then fourth and fifth, it will skip and it will provide us sixth position. This step is nothing but how many positions we need to step ahead, okay, instead of considering them. Same thing with the negative indexing. But in case of negative indexing, we need to do it in steps of -1 or -2. Since we are coming from end to beginning, we need to kind of decrease our steps. It's consider it as like positive index is climbing up and the negative index is climbing down. Okay, climbing down will always do it from end to beginning, right? So, and also, okay, before going forward, we'll just cover this slicing aspect as well. Let's say we have this hello string with us, and I am wanted to access all the characters from position 5 to end of the string, okay? And if you see, these are the first five, right? Okay, these are the first 0, 1, 2, 3, 4, 5, okay? It will skip first 5 characters, and starting from 5, it will output me all the characters until end of the sequence, okay? Starting from comma.
Check what out.
Yeah.
This is the index number 1, index 2, index 3, index 4, right?
No, no, no. String, what will be considered as what? But each letter in string is index, okay? H will be at index 0, E will be at index 1. Each character in the string will be considered as an index position, not word, okay? Just be careful. It will change when we come to list. If we need to hold a sequence of words instead of letters, then we can do that using list or tuple, okay? Here, each letter will be an index position. So when I'm doing st of 5, it will skip first 5 indexes, first 5 letters basically. And I'm trying to access letters 5 to 10, okay? And I can do that using this. Like if it will start at minus, if you carefully observe, it will treat even space as a index. Okay, space as a character. It will do any space or any special character. Python will consider it as a character within string. So in this case, even spaces are considered as characters. So that's why you can get result in this form. It will start at 5, 5, 6, 7, 8, 9. Since the index 10 is exclusive, it won't provide us the 10th value of this range, okay? And let's say I'll be accessing it from 0 to 10, 0 to let's say 14 in steps of 2. Okay, what I am doing is I am starting from 0 and I am going till 14th index in steps of 2. It will be skipping 2 bits, okay, once, okay. This is first position, right? It will skip the, sorry, 0th one, right? It will skip the first one. It will give me second one. Again, it will skip the third one. It will give me fourth one. So in multiples of, it will just keep on going in multiples of 2 basically. And then it will skip the fifth one. Then it will give me sixth one, which will be the space. Same thing, seventh one and eighth one. We can use it for stepping, accessing index in steps, okay? And then coming to negative index, if we give st of -1, it will just give me g, which is the last available position. So now I'm performing slicing. If I do this thing, the Python will throw error. Okay, sorry, not error. It will give nothing. The reason being, this is -1 available to me. But from -1 to, we are trying to go behind, but we are not defining any step here. We are trying to access this part of the string -1, -2, -3, -4, -5. We'll be basically getting string. We are expecting that, but we are unable to get this. The reason being, when we are using negative index, Python will kind of expect us to increment back, okay, in steps of -1, or we need to start from start and end. Okay, here what we are doing, we are starting in the end, and we are kind of trying to come behind without using the step. So if I'm using -5 and -1 here, then I'll be kind of getting the expected output, which will be string. Okay, and let's say I have this -1 here and -5. I can accomplish same thing in steps. Okay, I can just do -1 as a negative step, and it will start from last subset last one z, and from it will start from z and it will come back z n I r. Okay, since we have given from n to n minus 5 in steps of -1, it starts at end and it will come behind in the string. Okay, this is for indexing. Sorry, indexing and slicing. And then since string is a sequence, we can loop through it. Like we can using for loop, we can access each and every character from the string separately. So for loops we'll be covering in detail, but just for our understanding, let me do for character in string print of ch. What this will be doing, it will be accessing each and every element of the string and it will print it out to console using for loop. Okay. We can also, what we can do, checking for what. So we have this membership operator, right, which we have covered in operators. So we can use the same operator and we can check. Let's say we have this hello in st. So this is basically it's checking for whether hello is present in string or not. So what is the output which we can expect from this? Okay, what we are expecting and what is the actual output which we'll get when we execute this string? Okay, now I am executing this,
True.
performing this
True, sir.
membership operation hello in st. What will be the result of this? Like anyone can answer,
True,
like
sir.
if you have any idea.
True, sir. True.
Hmm? Will it be true or will it be false? Because membership will give us only two
Membership
things.
is
One can be true or one
false.
can be false.
False.
False. False or true?
True.
Okay. So just remember, these are the places, the reason which we are covering each and every aspect, starting from the minute detail is this sort of things. Okay. Python is case sensitive. In our string, we have capital H in our case, but in our comparison, we are doing it using the small h. So Python will treat this and this as different words. The reason being, Python is strictly case sensitive. Hello and like first hello and second hello are completely different for Python. Okay. So we can use this operation for performing membership operator to check if there are any words present. Let's say we have some list of strings available, some student name. We have some students, like some 1,000 students with us. I need to identify all the students with name Arun in them. We need to identify whichever student is having Arun in his name. We need to pick out them. So in that case, we can't manually go and check each and every student, right? So we can just using for operator and with the sequence available with us, we can perform this thing. Like if Arun is present in string, like Arun in name, just return that name. Else, just skip it. Okay. So for performing these sort of membership operations, we can use this in and not in. So if I'm performing not in here, in this case, it will evaluate to true. The reason being this hello is not present in string. Okay. Just remember Python is always case sensitive strictly. Either when you are defining variables or when you are defining strings, just keep in mind. Okay.